Right now, your car could be quietly deteriorating from the inside out, as rust, often unnoticed at first, gradually eats away at metal components and leads to billions in vehicle damage every year across major markets like the UK and the US. Most drivers have been led to believe that once rust takes hold, the only solutions are expensive professional repairs or replacing the vehicle altogether, reinforcing the idea that cars are ultimately disposable. But there's a lesser-known approach rooted in decades-old engineering practices, particularly from Japan, where specialists developed simple yet effective chemical treatments designed not just to cover rust, but to chemically convert it into a stable, protective layer. Unlike some modern coatings that can trap moisture and unintentionally accelerate corrosion, these methods focus on stopping the underlying reaction itself. While the automotive repair industry is largely centered around high-cost solutions, these alternative techniques highlight that rust treatment doesn't always have to involve sanding, grinding, or major expense. If your vehicle has early signs like bubbling paint, surface corrosion, or stuck components, understanding how these chemical processes work could completely change how you deal with rust, and potentially extend the life of your car far beyond what you thought was possible. To understand how a simple, low-cost powder can rival, or even outperform, traditional repair methods, it helps to look at the chemistry behind rust itself, specifically a process known as oxide conversion. Conventional rust repair usually involves sanding or grinding away the visible corrosion, but this approach has a hidden flaw. It often leaves behind microscopic particles of iron oxide embedded deep within the pores of the metal. These tiny remnants act as seeds, allowing rust to return over time, sometimes even more aggressively. In contrast, certain chemical treatments, often based on organic chelating agents, work through a process of selective bonding at the molecular level. When mixed with water, these compounds form a solution that actively seeks out iron oxide, breaking its bond with the underlying metal while leaving the healthy steel untouched. Rather than removing material, this method transforms the corrosion itself. This type of chemistry has its roots in demanding environments such as aviation and marine engineering, where metal components are constantly exposed to moisture and salt. Instead of weakening the structure through abrasion, the liquid penetrates into microscopic crevices and neutralizes the reactive properties of rust. During this process, the unstable iron oxide is converted into a more stable compound, often magnetite, which forms a dark, protective layer over the surface. This layer acts as a barrier that is far less prone to further corrosion, essentially halting the chemical reaction that causes rust in the first place. Compared to traditional primers or coatings that simply sit on top of the surface, this conversion layer integrates with the metal itself, offering longer-lasting protection. The key advantage of this approach is that it addresses the root cause rather than the symptoms. Instead of repeatedly sanding, repainting, and sealing, only for rust to reappear, this method interrupts the corrosion cycle at a chemical level. While no solution is truly permanent under all conditions, especially in harsh environments, converting rust into a stable compound can significantly extend the lifespan of treated components. In that sense, it represents a shift away from older maintenance cycles toward a more preventative, chemistry-driven strategy for preserving metal. It's tempting to assume that if a simple, low-cost solution truly solved rust problems, it would be widely promoted, but the reality is a bit more grounded in how the automotive repair ecosystem works. Most local mechanics rely on standardized, proven repair methods that are consistent, warrantable, and compatible with a wide range of vehicles and conditions. Professional rust repair often involves labor-intensive processes, not just because of profit, but because severe corrosion can compromise structural integrity, requiring thorough inspection, material removal, and protective finishing to ensure safety. While inexpensive chemical treatments do exist and can be very effective in certain situations, especially for early stage or surface rust, they are not always a one-size-fits-all solution, particularly when deeper structural damage is involved. The idea of a recurring revenue model in automotive care isn't entirely wrong, but it's also not a coordinated effort to hide simple fixes. Vehicles are complex systems exposed to harsh environmental conditions, and wear over time is unavoidable. Rust, in particular, is influenced by climate, road salt, humidity, and maintenance habits, which is why prevention and early treatment are so important. In recent years, there has indeed been a shift toward more sealed components and software-driven systems, which can make DIY repairs more challenging. However, this trend is often tied to performance optimization, emission standards, and safety regulations, rather than a deliberate attempt to eliminate consumer-level maintenance. In places like Japan, where vehicles are often maintained meticulously and environmental conditions differ, fleet longevity can be higher, but that's typically due to strict inspection regimes, regular servicing, and controlled usage rather than reliance on a single, hidden chemical solution. While some industrial-grade or less commercialized products may not be widely marketed, it's usually because they are specialized, require careful handling, or lack the certifications needed for consumer distribution, not because they are being intentionally suppressed. Ultimately, while low-cost treatments can absolutely play a role in rust prevention and management, the broader picture involves balancing cost, safety, reliability, and long-term durability, rather than relying on a single overlooked fix. If you're dealing with rust and want a practical, low-cost way to treat it without heavy sanding, there are simple chemical methods that can help, especially for light to moderate surface corrosion. However, it's important to approach this realistically and safely, because not all rust can be reversed, and structural damage still requires proper repair. That said, here's a grounded version of a no-sanding style approach, using commonly available mild acids like citric acid, which are often used in rust treatment. First, you identify a suitable rust removal agent. Citric acid is widely available, relatively safe compared to stronger acids, and commonly used for cleaning and descaling. Oxalic acid is also used in some rust removers, but it is more hazardous and requires extra caution when handling. For most DIY users, citric acid is the safer starting point. Next, you prepare your solution by dissolving the powder in warm water, typically around a 1:10 ratio, 1 part powder to 10 parts water. Warm water helps the solution activate and improves its ability to penetrate rusted surfaces. For application, instead of sanding, you can soak a cloth or sponge in the solution and apply it directly to the rusted area. For smaller parts like bolts or brackets, soaking them fully in the solution works even better. On larger surfaces, keeping the area wet, either by wrapping it with a soaked cloth or reapplying periodically, is key to allowing the chemical reaction to continue. Over several hours, anywhere from 2 to 12 depending on severity, the rust will begin to loosen and dissolve. You may notice the reddish-brown corrosion darkening or lifting away. This indicates that the acid is reacting with the iron oxide. After the treatment period, rinse the area thoroughly with clean water to remove any remaining acid and residue. This step is crucial because leftover acid can continue reacting and potentially damage the metal over time. Once dry, you should immediately apply a Past Panave layer, such as primer, oil, wax, or a dedicated rust inhibitor, to prevent oxygen and moisture from restarting the corrosion process. This sealing step is just as important as the removal itself. While this method can be very effective for surface rust and seized components, it's not a miracle cure. It won't restore deeply pitted or structurally weakened metal back to factory strength, and in those cases, mechanical repair or replacement is still necessary. But for early-stage rust, maintenance, and extending the life of parts, this kind of chemical treatment can be a simple, affordable, and surprisingly effective alternative to aggressive sanding or costly shop work.